We are going to learn about the equivalence between pushdown automata and context-free grammars, specifically focusing on how to convert a pushdown automata into an equivalent context-free grammar. Let P equal to Q sigma gamma del Q naught Z naught null. Q is a finite set of states. Sigma, the input alphabet, that is set of input symbols. Gamma, the stack alphabet, that is set of stack symbols. Del, the transition function. Q naught is the starting state. Z naught, the initial stack symbol, that is an element of gamma. Last, null, the set of accepting or final state. In the first step, set of variable capital V in the grammar corresponding to non-terminal symbols. Among these variables, there is a special non-terminal symbols denoted by capital S, which is designated as the start symbol of the grammar. Here P, X, Q, P and Q states in Q. This denotes a type of non-terminal variable used in the conversion from pushdown automata to context-free grammar. Pxq is a variable that represents the possibility of going from state P to state Q, processing input and manipulate the stack in way that X is removed from the stack. P and Q are both states from the set capital Q of the PDA. X is the stack symbols in gamma. Capital X used in the notation Pxq is a symbol from the stack alphabet gamma of the PDA. It refers to the stack symbol that needs to be processed or matched during the transition between pushdown automata states. Next, terminal symbol sigma equal to T equal to set of input symbols. This line defines the set of terminal symbols of the grammar. Sigma, which is the same as terminal symbol T, represent the input alphabet, that is the terminal symbols of the context-free grammar. It includes the set of input symbols that the PDA can read, which corresponds directly to the terminal symbols in the context-free grammar. Next, rules for converting a pushdown automata into context-free grammar. It defines how transition in a pushdown automata translate into production rules in a context-free grammar. In rule 1, if del of QAZ equal to P comma epsilon, then the context-free grammar production is Q Z P tends to A. In this line, the PDA moves from state Q to state P on input symbol A by popping Z from the stack and pushing notation, that is popping Z. Correspondingly, in the context-free grammar, the non-terminal Q Z P produces terminal A. Second rule, del of QAZ equal to P comma Y. Then the context-free grammar production is QZR tends to A of PYR. The PDA moves from Q to P on input symbol A, replacing Z with string Y on the stack. In context-free grammar, the production expands QZR into terminal A followed by a non-terminal PYR. Coming to third rule, if del of QAZ equal to P comma XY, then the context-free grammar production is QZS tends to A of PXR RYS. The PDA replaces top stack symbol Z with XY, two symbols, and moves from Q to P. The CFG breaking it using an intermediate state R and combining productions for both X and Y. Coming to the first problem, conversion of pushdown automata to context-free grammar. PDA formally defined as a 7 tuples. Here M equal to Q0 Q1 set of states 0, 1. The input alphabet, that is sigma. Next, stack alphabet Z0, X, that is gamma. Del transition function, Q0 is the starting state, Z0 is the initial stack symbol, null, set of accepting or final state, where the transition function del is defined as del of Q0 1 Z0 equal to Q0 X Z0, del of Q0 1 X equal to Q0 XX. Next, del of Q0 0 X equal to Q1 X. Del of Q0 epsilon Z0 equal to Q0 epsilon Next, del of q1 1 x equal to q1 epsilon. Last, del of q1 0 z0 equal to q0 z0. As we know that the context-free grammar is defined as VTPS. V means variable or non-terminal symbols, T terminal symbols, P production, S is the starting symbol. In the first step, we need to find out the non-terminal symbols, capital V. Non-terminal symbols are of the form PXQ, where P comma Q belongs to capital Q, X belongs to gamma. Here Q is a set of state. In the question they are given set of states Q0 Q1. Here you write Q0 Q1. X belongs to gamma. Gamma going to be a stack alphabet, that is Z0 comma capital X. From this we have to write non-terminal symbols capital V. S is the starting point of the grammar. It tells us where to begin when converting the PDA to a grammar. We are given two states Q0 and Q1 and two stack symbols Z0 and capital X. To construct the necessary context-free grammar variable, we consider all possible combination of these states with each stack symbols. First, take the stack symbols Z0 by combining it with the two states Q0 Q1. We get the following context-free grammar non-terminal symbols Q0 Z0 Q0. This represents starting in Q0 using the stack symbol Z0 and ending in Q0. Then Q0 Z0 Q1 starting in Q0 use Z0 and end in Q1. Next, Q1 Z0 Q0 start in Q1 use Z0 and end in Q0. Q1 Z0 Q1 start in Q1 use Z0 and end in Q1. Next, take the stack symbol X. We again combine it with all the state pairs to obtain Q0 X Q0 start in Q0 use X and end in Q0. Next, Q0 X Q1 start in Q0 use X and end in Q1. Q1 X Q0 start in Q1 use X and end in Q0. Q1 X Q1 start in Q1 use X and end in Q1. These combinations are essential for constructing the context-free grammar equivalent of the given pushdown automata, as each represents a variable used in the context-free grammar production rule based on pushdown automata transition. In step 2, terminals denoted by capital T or sigma. Here terminal symbols are 0, 1. Here you write T equal to sigma equal to 0, 1. In step 3, we take each PDA transition function one by one and apply the corresponding context-free grammar construction rules as per the defined procedure. By systematically solving each transition, we ultimately derive the complete context-free grammar. Let's take the first transition function del of Q0 1 Z0 equal to Q0 comma X Z0. In the given PDA, we have two stack symbols X Z0, which means there are 2 into 2, 4 possible combination for stack symbol transition. We have to write 4 lines. 2 stack symbols means we have to apply third rule del of QA equal to P comma XY. Then you will get the context-free grammar production. QZS tends to A of PXR RYS. As per the rule, we have to write the context-free grammar production Q0 Q0 Z0 Z0, then 1 place it here, next Q0 X, and finally Z0 place it here. Whatever the symbol you have written in the first line as per the procedure, make sure to use the same symbol consistency in the remaining 3 lines as well. So Q0 Z0, here Q0 X Z0, next Q0 Z0, Q0 X Z0, last Q0 Z0, Q0 X Z0. But we don't know the value of S and R. How do you find out the value of S and R? In the question they are given 2 states Q0 and Q1, which gives 4 combinations of state space. That is Q0 Q0, Q0 Q1, Q1 Q0 and Q1 Q1. Then write here Q0, 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 Q1, Q1, Q0, Q1, Q1. In place of the variable capital S, you must use that same symbol consistency wherever S appears in the production. Here S value going to be Q0. Wherever S appears in the production. See the rule. S appeared here. So you write Q0 here. Next Q0, Q0, Q1, 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 Q1. Likewise, in place of R, you must use that same state throughout the grammar wherever R is referenced. Here Q0, Q0, Q1, Q1, then Q0, Q0, Q1, Q1. In second transition function, del of Q0 1x equal to Q0 comma xx. In the given PDA, we have two stack symbols xx, which means there are 2 into 2, 4 possible combinations for stack symbol transition. We have to write 4 lines. 2 stack symbols means we have to use rule number 3. Del of QA z equal to p comma xy. Then the context free grammar production going to be q z s tends to a of p x r y s. As per the rule, apply the production q0 q0 x x, then 1, write it here q0 x x. Then whatever the symbol you have written in the first line, make sure to use the same symbols in the remaining 3 lines. Then Q0 x tends to 1 Q0 x x. Similarly, Q0 x tends to 1 Q0 x x. Last line Q0 x tends to 1 Q0 x x. We have 2 states Q0 and Q1, which gives 4 combinations of states where Q0 Q0, Q0 Q1, Q1 Q0 and Q1 Q1. Then write here Q0, 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 Q1, Q1, Q0, Q1, Q1. In place of the variable S, you must use that same symbol wherever S appears in the production. So write Q0, 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 Q1, 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 Q1. Likewise, in place of R, you must use that same state throughout the grammar wherever R is referenced. Q0, Q0, Q1, Q1, Q0, Q0, Q1, Q1. Next transition function, del of Q0 0 x equal to Q1 comma x. In the given PDA, we have one stack symbol, that is x, which means there are 1 into 2 possible combination for stack symbol transition. We have to write 2 lines, single stack symbol, which means we have to follow rule number 2. Del of QA is equal to p comma y. Then the context free grammar going to be QZR tends to a of PYR. In the given format, we have to frame the sentence Q0 Q0 x x, then 0, write it here Q1, then x. In the second line, Q0 x tends to 0 Q1 x, but we don't know the value of R. We have 2 states Q0 Q1, which gives 2 combinations of states where Q0 Q0, Q1 Q1. Then you will get the context free grammar productions. Next transition function, del of Q0 epsilon Z0 equal to Q0 comma epsilon. By applying a first rule, del of QA Z equal to P comma epsilon, then CFG production going to be Q Z P tends to A. In this format, we derive Q0 Q0 Z0 Z0 Q0 Q0 tends to epsilon. Fifth transition function, del of Q1 1 x equal to Q1 epsilon. Then the grammar rule is del of QA Z equal to P comma epsilon. This applies when a symbol is popped from the stack and not replaced. So QZP tends to A. In this format, we will frame the line of context free grammar since stack symbol X is popped without replacement, then Q1 Q1 X X Q1 tends to 1. Next transition function del of Q1 0 Z naught equal to Q naught Z naught. In the given PDA, we have single stack symbol, which means there are 1 into 2 possible combination for stack symbol transition. We have to write 2 lines. By applying rule 2, del of QA Z equal to P comma Y, then you will get QZR tends to A of PYR. In this format, frame the context-free grammar productions Q1 Q1 Z0 Z0. 0 place it here. Next Q0 Z0. Whatever symbol you have written in the first line, make sure to use the same symbol in the remaining line. Q1 Z0 tends to 0 Q0 Z0. We don't know the value of R. We have two states Q0 Q1, which gives two combinations of states where Q0 Q0 Q1 Q1. Then write here Q0 Q0 Q1 Q1. So we found non-terminal capital V, terminal T, then production. Last one, start symbol. The start symbol in a context-free grammar derived from a PDA is usually S tends to Q0 Z0 P. For all accepting state, P belongs to Q, where Q0 is the starting state and Z0 is the initial stack symbol. In this line, as per the question, we have two states Q0 and Q1. Instead of P, have to use Q0 and Q1. Then you will get two production S tends to Q0 Z0 Q0 or Q0 Z0 Q1. This represents multiple derivations toward different accepting states. Then finally, we will write the context-free grammar. How do we write the context-free grammar? In the first step, for the non-terminal set capital V, we wrote all possible combinations of states with the stack symbol Z0 and X placed in the middle. Each of these combination is now assigned a unique name for simplicity, starting from A, B, C, D, E, F, G and H. Similarly, in step 3, wherever these combinations appears, we replace them with their corresponding names A, B, C, D up to H and so on. Each and every transition function, totally we have 6 transition function. We replace them with their corresponding names A, B, C, D up to H. In third step, look at the first transition function, second transition function, third transition function and fourth transition function and fifth transition function and last transition function. We replaced them with their corresponding names A, B, C up to H. Then in the starting symbol Q0 Z0 Q0 replaced with A, Q0 Z0 Q1 replaced with B. Then write context-free grammar S tends to A, B. After that, A tends to 1 E, A. Then write 1 E, A. Next, A tends to 1 F, C. Here you write A tends to 1 F, C. Then wherever A production appears, write it here. Here A tends to epsilon. Write A tends to epsilon. Likewise, write all the productions B, C, D, E, F, H. Look at the context-free grammar. Here there is no G production. Wherever G appears, eliminate the productions 1F, G, 0, G. Then E production going to be E tends to 1 E, E. E is not derivable. Wherever E appears, eliminate it 1 E, F, 1 E, B, 1 E, A. Because E is not derivable. Then D is not derivable, eliminate it. So B production going to be cancelled. On simplifying grammar, you will get S tends to capital A tends to 1FC or epsilon, C tends to 0A, F tends to 1FH or 0H, H tends to 1, which can be reduced to S tends to A tends to 1F. Instead of C, substitute 0A, you will get A tends to 1F 0A, balance epsilon. Next, F tends to 1FH, By replacing H, you will get F tends to 1 F1 or 0 1. Hence, the context-free grammar is obtained from the given PDA. I hope you all understood the conversion of PDA to CFG. If you have any questions or need further clarification, feel free to leave a comment below. Thank you for watching.